Okay, so we're going to do notes 9-3 in your book. It's composite figures. What composite means is when we are pushing together two or more shapes to make another shape. And what we have here for our first one, we'll just kind of do a warm-up just to kind of remember what we're doing here is find the area of each figure. Now we have a rectangle in which B is the 14 and height, h, is 5. Well, we know that area of a rectangle is base times height. Okay, so we always start by writing down that formula. Now, if they want to know the area, well, we're given the base, so we'll just 14 in for B, and we're given the height, which is 5. So 14 times 5, and we'll have to get out a calculator here to kind of do that math. Yeah, and it looks like 70. So our area is going to equal 70, and this is in centimeters, so 70 centimeters, and squared. Remember, this is a two-dimensional shape. When you take one dimension times another, you'll get a two-dimension, and so it is squared. Area is always squared. Okay? Let's look at number 2, a triangle, in which they give you the base and the height again. So we start by writing down the formula for area of a triangle, which is 1/2 base times height. Again, you can write that several different ways. This is just one way of looking at it. And I'm going to go ahead and plug in the values that they give us here. And they give us, looks like the base, which is 6, so we'll put that in there for B. And they give us the height, which is 18. Excellent. Okay, so now we're going to find out the total area, and we're going to have to do some math here, but we'll go ahead and multiply 0.5 times 6 times 18, or we can multiply 18 times 6 and divide by 2. So it looks like we're going to have 54 inches squared. Okay, so that's pretty good of warm-up. Just getting going over the formulas for area of a rectangle and area of a triangle, just kind of recapping on that. Looks pretty good. All right, number 3 here. It looks like we've got a trapezoid, which is another warm-up here. Base 1 plus base 2, and we got the height. So again, start by writing down the formula for area of a trapezoid. And we know it's 1/2 base 1 plus base 2 times the height. And again, all we're going to do here is plug in the values that we know. We got the 1/2, and it looks like base 1 is 7 plus base 2, which is 11, times our height, which is 3. And again, we can go through and simplify this, which 7 plus 11 is 18 times 3. Okay. So, do the math again. We can do it several different ways, put it in our calculator. But if we do multiply it out, we can take 9 times 3, which is half 18. Half 18 is 9 times 3. So it's like 27. So our area is 27, and this is in feet, so 27 feet squared. Excellent. Looking pretty good. Alright, so now if we want to start looking at composite figures, and again, that is more than one shape pushed together here, this is the first one we're going to look at, and it looks like in this picture we've got a trapezoid right here. Okay, everybody can kind of see that trapezoid, and we have a half circle on the top. Alright, so what we want to do is we want to find the area of the trapezoid first. So let's write down the formula for that. So 1/2 base 1 plus base 2 times the height. Okay, there's trapezoid. And we know we're going to have to add to that the area of this half circle. Okay, so pi r squared is the formula for area of a circle. Now here we only have half of it, so I'm going to stick a half in front of this formula because I know I only need half the circle's area. Okay, so let's start with the trapezoid. I've got 1/2. Looks like my base here is 20 and my other base is 32. Again, a good idea to remember the bases. They're the two sides that are parallel. Okay, and yep, there's always going to be two sides that are parallel on a trapezoid. Now our height always hits the bases at a 90-degree angle, so I know the height here is 14. So I can plug that in my formula right there. Okay, now let's go one more step. 1/2, let's add those two. We get 52 and 14. Excellent. Okay, so what we want to do is go ahead and multiply all that out. 1/2 times 52 times 14. It looks like we end up with 364 millimeters squared. All right, cool. So that's the area of our trapezoid. And if you guys don't mind, I'm going to write that in here. 364. That's the area of this trapezoid. Okay. Kind of highlight that there. That's done. Okay, and let's go ahead and let's move on to the next shape here, which is the circle. And we got 20 here going across. Remember, this 20 right here is our diameter. So if we want the radius, we need half of that. So half of 20 is 10, so keep that in mind. So we got 1/2 pi, and our radius is 10 squared. Well, we know what 10 squared is, right? Well, we should. 10 times 10 is 100. And we can take half of 100, which is 50 pi. All right, now if we are going to add these together, we definitely need to multiply this throughout by pi, because this is not in terms of pi. So in order to add them, we have to multiply this out, and we do get 157. It says round to the nearest tenth here, so 157.1. Okay, and again, this is going to be millimeters squared, same units of measure, which is nice. Okay, so we've got our two areas. And now, if we want our total area here, we are going to have to take these two and add them together. So let's take that 364 plus that 157.1 to get our total area. And we can put that in our calculator, and we should end up with 521.1 millimeters squared. And we've just found the area for our first composite figure, which is kind of cool. Okay, so far so good. Looks good. Let's see. Let's go to a little more trickier one here. And as you can see, this one's a little bit more complex. They're giving you a lot of parallel lines, and usually that signifies that we are dealing with something here, some kind of shape. And if we think about what shapes have parallel sides, you might think of a parallelogram. Let's take a look at that. And it looks like, yep, we got a parallelogram here, don't we? Okay, so if we can find the area of this parallelogram, and what's this other shape that's left over here? Excellent, you're absolutely right. It is a triangle. So if we've got a parallelogram and a triangle here, let's find the area of the parallelogram first, and let's go ahead and add the area of the triangle, and we will have the area of our shape. Okay? So area of a parallelogram is base times height. Same as a rectangle. Alright, well, if we look at our picture, it looks like the height goes from one base to another, and it looks like our height is going to be 5. And our base here that extends out straight happens to be 8. So 8 times 5. Well, what is 8 times 5? 40. Excellent. So we've got 40 feet squared for the area of our parallelogram. Okay, let's just keep that in mind. It's 40 here. Alright, now let's find the area of our triangle. Okay, and our triangle is right in here. There it is. Doot, 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 doot. We'll do this one in green. It'll be kind of nice. Okay, so to find the area of our triangle, write down the formula. Area equals 1/2 base times height. There's the formula for triangle. And it looks like they give us our base here, which is 10. Oh, and look at our height. How nice is that? 5. So 1/2 our base, which is 10, times our height, which is 5. 10 times 5, we got 50, right? 1/2 of 50. We all know what's half of 50. 2/4. That's going to be 25. And this is feet squared. Keep that in mind. We always want to square our units when we're dealing with area. Okay. Now, what we were asked to find was our total area. So in order to do that, we need to take these two, and we're going to have to add them together. Okay, so let's take 40 plus 25. Okay, I'm just writing it down here to show that work. And we've got 65 feet squared. So this is our total area of our shape. Okay, and that's not so bad. Once you see the shapes within the picture, as far as what you can cut them into, it makes it a lot easier from there. Now there's multiple different ways you could do this. Just keep in mind that I'm showing you one way. Okay? Alright, let's move on. And we've got a couple more here. Let's take a look. This one looks kind of cool. Let's go ahead and do this one. We could probably go ahead and draw a line here, a little dotted line. And you know that's going to hit right at a 90-degree angle here. We could probably figure out the area of this rectangle. So let's go ahead and do that first. And then we'll do the area of the triangle. So area of a rectangle, base times height. Our base here seems to be 37.5 and our height 22.5. So base 37.5 times our height, which is 22.5. Excellent. Let's go ahead and multiply those out. Let's see, 37.5 times 22.5. And you can put that in your calculator. And we get a composite, or I'm sorry, a total area for that rectangle is 843.75. Excellent. And remember, this is meters squared. So there's part one. Okay, let's head on over to part two here, which is the triangle. Alright, we need base times height. Well, this is 75 all the way across. Well, what is it from here to here? That's 37.5. So let's subtract that from 75. And, oh, it looks like this right here is 37.5 also. Excellent. Okay. Well, do we know the length from here to here? That's the question. And if you look at the picture, we do not. We need this length, because this is our height. There's our base. Okay, so how do we figure that out? Well, when you have a right triangle, what theorems do we know that can help find a missing side? You got it, the Pythagorean theorem. A squared plus b squared equals c squared. We're going to have to do this first to find the height to get to our area of our triangle. We know our area of triangle is 1/2 base times height. So we have the base, we got to figure out the height. And we do not know it yet. So let's find it by using the Pythagorean theorem here. So our a squared, we can call it h squared, because that's our height, plus our 37.5 squared equals our c squared, which is our hypotenuse here, 62.5. Okay, so 37.5 squared is 1406.25 equals, we gotta square that, 62.5 squared is 3090, oh, sorry, let me just erase that, 3906.25. This is plus h squared. So we know we're going to have to subtract this from both sides. So let's go ahead and subtract that. I'm going to minus that 1406.25. And we're going to end up with 2500. And we know we got a square root, both sides, to come up with h. And again, this is our height. So that's really cool because that's exactly what we needed to solve this. And that's going to be 50. Alright, so it looks like this height right here is 50. Let's look at our formula for the area of triangle now. Let's plug it in. 1/2 our base, which is that 37.5, times our height, which is 50. And again, if we multiply that out, we'll have to use our calculator here. We're going to get a total area for that triangle is 937.5. And again, this is meters squared. Now, to get our total area, we know that we're going to have to take these two and add them together. So let's go ahead and take 843.75 plus 937.5, and we're going to end up with a total area of 1781.25 meters squared. There's your total area for this composite figure. So sometimes we're going to have to do some extra work here. We had to do the Pythagorean theorem off to the side, but as soon as we got that, we were able to get our total area. That's excellent.